Andrea is the Director of Business Development for Keystone Engineering and Manufacturing Corporation. She is an active member of the Asphalt Recycling and Reclaiming Association, the National Asphalt Pavement Association, and the Association of European Road Milling Enterprises. Andrea earned her degree from Indiana University and resides in Chicago, Illinois. Please welcome Andrea.
Hi, good morning, everyone. Thank you so much for joining us here today. I have spent most of my life, all of my professional life, in and around the asphalt grinding industry. And I'm always excited to have a platform to discuss new technology. And today we will be discussing micromilling and the benefits of micromilling before pavement preservation treatments. During this presentation, I will be going over the difference between standard milling, fine milling, and micromilling drums, looking at the different factors that dictate surface texture, applications and advantages of micromilled surfaces, and we'll be focusing in on the Double-Grove Street project that was completed out with Los Angeles County, California. We'll also be touching on some new technology in milling as well. So to get started, there are three basic categories of milling drums: standard milling, fine milling, and micromilling. Micromilling and fine milling, very similar to standard milling, but with the intent on leaving a much smoother surface. Here we see a picture of a surface comparison. And as you can see, the micromilled surface on the left is much smoother and more uniform than the standard milled surface on the right. There are 6 determining factors of pattern generation, and bit spacing, forward cutting speed, wrap configuration, RPM, the diameter of the drum, and drum maintenance. The first factor we'll look at is bit spacing. This is a picture of just a standard milling drum. It's probably what you're all the most familiar with. It's a triple wrap by design, so it's got 3 coils that wrap their way around the drum, 5/8 of an inch spacing, 15 millimeters, and you'll see 5/8 of an inch surface strikes with the interaction of all 3 bits. So there's 1 bit on a line, and the only time you really ever see 5/8 of an inch spaces or surface strikes is when you have all 3 come around together. Here's an image of a fine mill drum. It's got twice as many bits as a standard milling drum. Also a triple wrap, 3 wraps, 3/10 of an inch spacing, and the only time you really ever see that 3/10 is, again, when you have the interaction of all 3 bits. And finally, a micro mill drum. Triple wrap, 2/10 of an inch spacing. Again, the only time you really ever see 2/10 of an inch spacing because of the wrap design is when all the bits come around and interact together. This particular system here with a drum with 3 times as many bits as a standard, you really should keep it for thin lifts, anything not to exceed 2 inches of milling depth. Now we'll take a closer look at how forward cutting speed factors into surface pattern. This is a great picture that shows just how misleading the spacing, the actual drum spacing, can be in a true production environment. This was a 5/8 of an inch spaced milling drum, but as you can see in the picture, you actually see line spacing of 5/8 of an inch just right here, 1.25 inches and an 1 7/8 inches. So as forward cutting speed comes into the equation, everything, the pattern, the surface strikes really begin to just spread out. In this AutoCAD drawing, you can see the difference exactly between what happens when you double the forward cutting speed. So from 35 feet a minute to 70 feet a minute in the surface strikes. At 35 feet a minute, you're seeing strikes at 5/8 of an inch, 1.25 inches. And at 70 feet a minute, you actually see 5/8, 1.25 inches, and 1 7/8 inches. side-by-side comparison shot. All the factors are the same except for forward cutting speed. Actually, same drum, just different forward cutting speeds. The pattern on the left, the rougher pattern, was generated at the faster speed. And when you really get moving fast with a triple wrap drum, you'll, for the most part, only see the lines. The surface strikes at 1 7/8 inches. Here's a picture that a lot of people in the field refer to as the milling machine was outrunning its cut. You can see it, or V'ing out, so to speak. And the V's created by the wraps of the drum. It's from the right to the left, bringing the material in, so you can kind of that being reflected, seeing it reflected down on the surface. Okay, we've seen the negative effects that forward cutting speed can have. So now we can look at different wrap designs and try to understand wrap designs and try to minimize those effects at production speeds. The industry originally started with double wrap designs. You had 2 wraps, and they were at 1.25 inches, and then the second wrap would split that at 5/8 of an inch. But after the milling machines started becoming more and more powerful, forward speed, you had the capable of really producing a lot more. The industry switched to triple wrap design, and that's really the standard it is still today. It allowed you to mill about 50% faster than the double wrap designs. But now we're starting to see more and more requests for quad wrap designs. And quad wraps have 4 starts, and the wraps at 0 and 180 degrees repeat. So you actually have a double hit. In that double hit, that repeating tooth knocks down the longitudinal ridge that you'll see in patterns. So it really smooths it out and leaves a much more uniform pattern. There's some other positive features for double or quad wrap designs as well. Bit consumption tends to go down, and you create a smaller gradation of material. So for the wrap processing side, for maintenance, as far as the conveyors and whatnot, moving smaller material, there's a lot of benefits other than the uniform surface that it creates at the faster speeds. Here's a side view of the difference between a triple wrap and a quad wrap drum and the degrees between the spacings. And in this picture shows the surface strikes of all the different drum designs that we've talked about so far at the same forward cutting speed. So the 2 on the left is kind of your all-purpose milling drums, the drums that can handle full depth, no problem. And the 5/8 of an inch triple wrap at 70 feet a minute, your quad wrap at 15/16 of an inch, and your fine milling and micro milling drums. This is a great picture because spacing can be very misleading. And both patterns were produced from a fine mill drum, but the smoother one, the pattern on the left, the spacing was actually larger. It had a wider spacing than the one on the right of 0.45 inch because of its quad wrap design. In a production environment, it's actually much smoother than the tighter spacing. And also likewise, here's a drum, a fine milling drum, versus a standard quad wrap drum that has 100 less bits at a faster production speed. Actually creates a smoother pattern. The remaining factors, RPMs, equally as important as forward cutting speed, but generally far less volatile. The diameter of the drum, usually set by the manufacturer. The larger the diameter, the longer the arc, the smoother the pattern. And cutter drum maintenance, because even if all the factors are the same, if you have a poorly maintained drum, you can always end up with a pattern such as such as the one on the screen. And to prevent such patterns, we really need to look at the specifications and acknowledge that equipment specs do not always ensure that we get the pavement, the final surface that we're looking for. And due to the impact of the multiple variables that we discussed, we've found that performance-based specifications are most useful for making sure that we get the smooth pattern, especially when we're looking at combining it with thin lift treatments, preservation treatments. In Georgia, the DOT years back, handful of years, probably 5-6 years ago now, looked at a micromilling specification for doing open graded friction course removal. They just wanted to remove only the open grade, the surface course, and they felt that they needed a really smooth surface to put the surface course back on to make sure that the water could drain properly. And they implemented a performance-based specification, laser road profilograph, and it not only measured the ride of the road, but also the surface texture. And it would look specifically at the peaks of the valley of the milled surface. So as long as it was under a certain amount, those ridges were small enough, the state felt that they didn't need to remove multiple lifts to repave the road, multiple lifts. They could just get by with removing the surface course, and it, obviously save the state a lot of money. Virginia has another nice performance-based specification. They use an ASTM spec, the sand patch test. Their main concern was to, make sure that they received a smooth surface for the motoring public. So if they didn't necessarily have to mill and fill, if there was some milled surface exposed for the motoring public, that it would be a smooth surface to operate on. There are many different applications for micromilling. The ones we're going to focus on today is on a ride corrective tool and a surface prep tool before preservation treatments, lift overlays. Same with advantages. We're going to look at some of the advantages here, specifically how it relates to pavement preservation treatments. The first, I think the most important is looking at it as what it can do to improve rideability. Because with the ability to go through and micromill a road, you're really going to open up a lot of roads that, for pavement preservation, that may have once been looked at as, hey, these are too rough. These roads are too rough. They need a mill and fill or heavier, reconstruct. And so you're going to open up a lot of roads, saving a lot of money as far as material goes. The other benefit, obviously prepping a surface properly, removing all the old oil slicks, removing the paint, reducing the size of the surface cracks before putting your surface treatment on, only will increase the life of the treatment. Restoring curb line, requiring less material, saving money as far as that goes, especially versus standard milling. And public perception. So not only are you enhancing the road, but you're also creating a surface that is noticeably smoother when you're driving. So we're going to focus in on a job down in Los Angeles County that the County of Los Angeles completed last year, in the spring of last year. And the County of LA has a really strong pavement preservation program. They started doing micromilling in conjunction with pavement preservation back in 2009. They expected that they would see an average life of the treatment lasting anywhere from 6 to 8 years. 7 years in, they have now been able to bump that to 8 to 10 years. So they've got some good reasons to be positive about pavement preservation. It's the largest county in a very large state of California. There's 88 cities within the county, 7,400 lane miles. It has a very diverse climate, from coastal to desert to mountain. So they're kind of all over the place there. And one of the things that the county does that's unique is they call it their it's a job order contract process. And it's still a form of low bid, but the county will provide the contractors a price book for each particular pavement preservation treatment. And then the contractor will bid on a factor of the book. And annually, the contract is for about $4.5 million. But they're only guaranteed to let out $50,000 worth. So if they get a contractor that is doing poor work, they're only guaranteed to give out, one job at $50,000. If the contractor's doing great work, they like what they see, they continue to let jobs out, and it forms it can form a very nice relationship. I guess it goes the other way as well, but when you have that, the contractor has to kind of continue to sell their work at the same time. And, they have a self-performing requirement, a high one of 90%. And they have felt that by having this higher self-performing requirement, that they're getting a better pool of contractors. They're more qualified and more preservation focused to do the work. And probably one of the best features is the pre-walk, where the county and the contractor walk the job before the beginning of the job and, check out the project, see if there's any issues that maybe, either one of them didn't spot before, and then figure out a game plan from there. And it almost results in no change orders once the job actually begins. So the benefits for the county and the benefits for the contractor, it's really no surprise that there's one that sticks out as a benefit of both. And that's the partnership that the job process really creates, where the county and the contractor are working together. It just really nice collaborative relationship is formed. So the particular project that we're going to look at is the Doublegrove Street project. Doublegrove is a residential neighborhood in Los Angeles County, and they were looking at a cape seal. They wanted to micromill to get some smoothness, to restore smoothness before a cape seal treatment. The PCI index was 56, had a rather large job, 2.2 million square feet of extensive amounts of alligator and map cracking throughout, and a lot of areas that needed full depth patching of some failing asphalt that they needed to address first. Total job cost was $1.65 million, and it was completed May of 2015. When they first started looking at their options, there really wasn't many. Thin lift overlay, surface treatments, the road was just too rough. And, they didn't have the money in the budget to address a full reconstruct, which is really what it needed. So the county decided to look at a hybrid approach. They would first micromill the road to improve the ride, restore the curb line, and then overlay with a cape seal to extend the life and also restore with a new riding surface. There's 4 main parts to the job. The first was asphalt patching. There was, again, an extensive amount of patching that needed to be done. The second, micro-milling, anywhere from 3/8 of an inch or less from the curb line out, and then just really shaving off high spots from there. A scrub seal, a rejuvenating emulsion, ARE, was used for the scrub seal process, and then covered with a 5/16 of an inch, 100% wrap shavings, or screenings, And the final wrap slurry seal. Again, type 2, 100% wrap slurry seal was used. Here's some pictures. We see the isolated alligator cracking, some failing asphalt conditions. Here we have some areas that were milled out, so the patching could be completed. Your milling process, pavement recycling systems used a Vertgen milling machine with a triple wrap 6mm drum to complete the job. Here's your final milled surface. The application of the rejuvenating emulsion, the surface before the chips were spread, the spreading, the 5/16 of an inch wrap chips, and a pneumatic roller was then used once they were down to just lock them in. And the final application of the wrap, 100% wrap slurry seal. So in this picture, you can see here the finished surface. And after 40 working days, the county was left with really a spectacular road, both for ride and the aesthetics. And really, it was very important, the aesthetic portion of it, because this was a neighborhood that 20% of it had been formerly overlaid with asphalt, just regular hot mix. And, you know, that could give the county some headaches if it was just a preservation treatment. Hey, you know, why so-and-so street, you know, hot mix overlaid versus, you know, ours, we just had a chip seal. So, you know, they just didn't get the complaints when they went through this phase. So again, it's not about just enhancing the road, but you know, restoring the ride, which is something people notice. And you know, as everyone in this room knows, ride's important. We're only going to see more you know, emphasis placed on it in the upcoming years. And it's always been the number, you know, the number one probably limiting factor to preservation treatments. So the job, you know, again, it was a success. It bumped the PCI up to 95, restored the curb line, and it used all the savings of $1.5 million almost, comparing it to the reconstruct methods. Additionally, the environmental impact was significantly less. 100% of the aggregates used on the job were recycled. There is one asterisk. Only the aggregate that was in the hot mix asphalt was had virgin aggregate in it. Reduction of 84% greenhouse gas emissions, 79% energy consumption reduction, 9,400 cubic yard landfill reduction. So the county did learn a few things. Micromilling, it's dusty, especially in residential areas. Vacuum trucks are really a requirement over your traditional brooms that you may use. Maybe some even training for the operators. Milling has always been a production focused industry, and really you need to put the emphasis on the surface pattern to create kind of new markets for this. And you'll see a rise in application rates, anywhere from 5 to 15% on the high side. So some other technology I wanted to discuss today is also drum technology that was developed for doing surface grinds. And it's very different in the sense that it doesn't use a conical bit that creates more of an impact or leaves the ridges that you see in micromilling. This particular drum system shears the surface. It uses an ultra-precise flat carbide. It's on a negative rake, so it shaves it. You get 100% surface coverage. So it would be perfect for surface prep before seal coats. So you can see the picture on the left of the final ground surface. And the attachment on the right, the flatliner, which was designed for just doing bump grinding for improving rideability, that uses this same type of flat tooth technology. And that's on an RCC, roller compacted concrete job, that just had some problems getting smoothness numbers. So in summary, I think, you know, by adding a micromilling process before a pavement preservation treatment, you're going to definitely increase your options for addressing some aging roads, especially with poor rides. You're going to see a significant cost savings on material and construction side. And at the end of the day, you're going to end up getting a better final quality product just by, properly prepping the surface and really maximize the surface treatment's lifestyle. So at this time, if there are any questions.
In terms of speed difference there, micro milling and then conventional milling, what's the operation speed, feet per minute?
Yeah, so that's kind of a tough one because it depends on, there's different factors. You want to go slower, but if you have different wrap designs, you're certainly able to run fast. Say with a quad wrap design, you could, run at 0.3 repeating pattern, you could run probably 60 feet a minute, no problem, versus if you had a triple wrap drum at 0.2 of an inch, you'd be down around 20 feet a minute to pass that same. So a lot of it just, I hate to just toss out a number and say, hey, this is what your production would be. This is what a speed requirement should be, because you can't just look at speed. You got to also look at the other factors. And, you can always kind of adjust around that by looking at different wrap designs. So you can increase your speed and still leave a nice pattern. I think there was a couple of questions back here. Brian? First question was, how long does it typically take to swap out a standard drum to micromill drum? And that really depends on the manufacturer. So because micromilling is becoming, you're seeing it all over the place. There are some manufacturers, they have quick change drum system setups where you can change them, they say in 3-4 hours. Other manufacturers, it may take a day to swap out the drum. It can be an extensive process. The second question had to do with the trimming around manholes and other utility cuts. Really, it's such a small amount of work that you would probably be fine with just a standard drum because you're going so slow anyways. So shouldn't really be. I certainly wouldn't look at any specifications for that. Question right here?
Hi, Andrea. I thought I heard early on that you mentioned micromilling to a depth of almost 2 inches. And I know in our area that's extremely aggressive for what
it would be.
What the micro would be. Would you mind going through kind of the ranges you would recommend for standard fine and milling and,
Sure.
and micromilling?
Sure. Typically 2 inches would be on the high side for micromilling. It all depends on what the material is and what size horsepower machine that they're using. Whereas in sometimes 2 inches, you could walk through it. Other times you'd be down 10 feet a minute or something. So I would say for micromilling anywhere under 1.5 inches. Sometimes when you're in the job, you need to allow to make a change if you're getting some splitting of lifts. So you need to be able to go plus or minus just in case you would have to do more once you figure out kind of what's under there. Fine milling, 3 inches would probably be the max there on there. Yeah. Right here?
With the typical standard or typical fine milling drum configuration, can you actually get a micro milling surface pattern simply with adjusting your forward speed, or is that not possible?
No, I mean it's just different. I mean, with fine milling, you have twice as many beds. So if you compared a fine milling drum and a standard milling drum at the same forward speed, one would be twice as smooth. Micro milling, you have about 3 times as many beds. So really at the same speed. So it's hard to, again, say, hey, put the emphasis on, creating speed requirements or, all these other things. Because at the end of the day, there's too many factors. Does that answer your question?
Question about the dustiness of it.
Oh, okay.
Is it more dust than a standard mill? Is it
Yeah.
it is more. So
Yeah.
can you take care of that with
Yeah.
water, or is it?
Yeah, water's good, because the other thing it does is it micro milling, with larger chunks. Imagine larger chunks kind of going through the drum, and water is used for multiple reasons on milling machines, not just for dust control, but for also cooling the bits. So water's good, but for dust, you generate much more dust, because you really get in. It's you're doubling, tripling the amount of bits, which is almost like creating like a whole crushing effect. It really is very much like a crusher. Some of the wrap gradation that comes off of micro milling, your fine counts go up, to large percents. So it's a crushing. It kind of turns into a crushing operation. So yeah, you can use water. A lot of times contractors will swap out their spray bar tips to allow more water to come out. Run water through the drum itself to try to get around that. So water's key as well. And there's certain machine manufacturers are installing vacuum systems on their conveyor belts that could help. But yeah, there's some different ways of controlling that.
Speaking of dust,
Mm-hmm.
are you familiar with the OSHA regulations? And they've been talking about them for about 3 years
Sure,
now.
sure.
That has
Longer.
our contract, or
Yeah.
maybe a little
Yeah.
longer. That has our contractors certainly concerned about it.
Sure.
And just as you said, water for dust suppression
Uh-huh.
and so forth. That becomes quite an issue for us because we have to tack after that,
Mm-hmm.
and we can't tack on a wet or damp surface. So you're familiar with, you're up to date on what's going on with OSHA?
Yeah. In fact, the Europeans have been looking into that for many years. And everything as far as the silica dust studies, all of that kind of came out positive, meaning we weren't seeing too much impact as far as negative health implications from dust. But as far as dust on the surface, water, if you can flush the surface, really the best way of addressing it as far as the concern of having dust on the streets would be open it up to traffic, because nothing's going to clean it like cars zipping down the road. Yeah. It's a, yeah. Mm-hmm. Yeah. Right. Yeah, leave a week window and get that surface. In Georgia, and they were doing that, I think on 75 or 85, whatever the highway is that goes down through Atlanta, and they just had really a lot of success. And James is going to be telling us more about what the Georgia DOT was doing, but that was one of the key things that they put in their spec, letting traffic ride on it for a few days, just to clean all that dust off of the surface.
Traffic does a good job.
Yeah, traffic.
So this is very good interaction. We'll do one more question, and then we'll move on.
Andrea, good presentation. Thank you.
Thank you.
The wrap screenings,
Uh-huh.
you referred to them.
Right.
How was that material processed?
Oh, okay. Well, we're going to, Don, will you be touching on that? The third presentation this morning, they're really going to get into that. So Don Matthews from Pavement Recycling, he's here, and he'll be touching on that. And it's really exciting stuff for preservation and recycling in general. So
Let's give Andrea a big hand. This is very good presentation. Thank you very much.